In this video, we're going to be putting together everything that we have learned in this section and a couple of the last few sections. So we are supposed to factor this completely, and we're supposed to sketch the graph of this polynomial. So let's get started. What is our end behavior, first of all? I know it didn't tell us to find all these pieces, but it'll definitely help us sketch the graph. So this is an odd degree polynomial with a positive leading coefficient, which means it makes that shape. So that means down on the left, up on the right. And if you want to be algebraic about it, you would say that as x gets smaller, y gets smaller. As x gets bigger, y gets bigger. Okay, so this is our end behavior. We'll work on that at the very end when we start to graph it. The next thing that we want to do is find all the rational zeros. So I'm going to call it the possible rational zeros. To find the possible rational zeros, you have to do your P's and Q's. So 9 is P, 2 is Q. Factors of 9 are positive and negative 1, 3, and 9. Factors of 2 are positive and negative 1 and 2. Your rational zeros are P's over Q's, so positive and negative 1 over 1, 1 over 2, 3 over 1, 3 over 2, 9 over 1, and 9 over 2. So these are our possible rational zeros. Remember, that means out of all the numbers in the whole universe, only these are the ones that are possible to be rational zeros of this particular function. Okay, now we want to actually write it in factored form. But before we do that, let's use Descartes' rule of signs so that we know how many of each zero to expect. So if we want to know the number of possible positive real zeros, we count the number of sign changes in the original function. So this is positive to positive, positive to negative, that's a sign change. Negative to negative, negative to positive is a sign change, and then positive to positive. So it looks like we could have two possible positive real zeros. I just want to double check. Okay. So we could have 2, but remember you have to reduce it by 2. So you could have 2 or you could have 0 possible positive real zeros. How about the negative ones? Well, to find the negative ones, we need to plug in a negative everywhere there, or negative x, everywhere there is an x. So P of negative x. Let's just do this one in our heads. So negative to the 5th power is a negative. Negative times positive is negative. Negative to a 4th power is positive. Positive times positive is positive. Negative cubed is negative. Times negative is a positive. Negative squared is negative. Sorry, negative squared is positive. Positive times negative is negative. Positive times negative is negative. And then bring down the plus 9. So let's count the sign changes. That would be 1, 2, 3. So it looks like we're going to have either 3 or 0. Sorry, 3 or reduce that by 2. So 3 or 1 negative real zeros. Okay, so let's get started testing our P's and Q's. So let's try P of 1. So we have 1 stow x enter. Type in our original function. I think I already have this in here somewhere. 2x to the 5th, 5x to the 4th, 8x cubed, 14x here. There we go. Oh, that's awesome. We already get a 0. So p of 1 is 0. That means 1 is one of our zeros. Let's do synthetic division. I'm sorry I can't fit all this on the screen at one time. See if we're missing any terms. 5, 4, 3, 2, 1, 0. We are not. So I'm going to put all of these coefficients into our synthetic division. Alright, let's go. So bring down the 2, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Hopefully we get 0 because that's what we determined here. So our factored form at the moment is x minus this number, reduce this by 1. So this started as x to the 5th. This one becomes x to the 4th, x cubed, x squared, x, and that's our constant. So then we get all of that. Okay, we don't know how to factor this one, so that means we need to do p's and q's again with just the stuff in that second set of parentheses. So we're going to do p's and q's for this one. Alright, we'll take a look. In the original one, our p's and q's, p was 9 and q was 2, right? 9 and 2. Well, that means our p's and q's are going to be the same for this one. So I'm going to just make a note. P over Q, same as above. Alright, so we know that 1 worked. We tried that here. 1 did work the first time. We didn't try anything else. So since 1 worked the first time, we really need to try it again to make sure it's not a double root. So let's go down to our new function. Type this in. Let's make sure. 2x to the 4 is 7x cubed minus x squared minus 50. I think that's right. And it does not work the second time. So let's try -1. -1 works. Just going to make a little note. So I stop, I do synthetic division just with this, and I have a -1 this time. 4, 3, 2, 1, 0. We're not missing any terms. Bring the first one down and multiply. Add, multiply, add, multiply, add, multiply, add. So right now, we go back to this line. We have p of x is equal to, we have our x minus 1 from before. We have x minus this, so x minus -1. And then we have this one, so we need to reduce this exponent by 1. That becomes x cubed, x squared, x. It almost looks like we could factor this by grouping. But here, if we factor out an x squared, we're left with 2x plus 5. Over here, we would factor out a -3. We'll be left with 2x plus 3. So factor by grouping doesn't work on this one, which means we have to do p's and q's yet again. If you look at this, aren't the p's and q's the same? So p over q is still the same as before. So we already tested 1 and we tested it again. It didn't work the second time. We tested -1 and it worked, but -1 might actually work for this one. So let's try -1 for this part of our function. We get 0. So we find out that -1 works again. So we stop and we do synthetic division. We're putting these numbers in 2, 5, -6, 9. Bring down the first one, multiply, add, multiply, add, multiply, add. So now we go back and grab our first two factors, x minus 1 and x plus 1. This is another x minus -1, so that makes another x plus 1. Then we have this one. We're decreasing this exponent by 1, so it becomes a square. So this is x squared, and this is x. So we have 2x squared plus 3x minus 9. So right now what we have is x minus 1, x plus 1 squared, because we have two of them, and this has to be factored using the AC method. I'm going to assume you know how to do that by now and tell you that it is going to be, to get 2x squared, we need 2x and x, and then we need some 3's here so that we get our 9. 2x minus 3, and that's positive. Let's just make sure. 2x squared, 6 minus 3 is 3. -3 times 3 is -9. So it does work. This is the completely factored form of our polynomial. You will be asked to do that on a test, so you want to make sure that you know how to completely factor your polynomial. Well, your polynomial is where you get all your zeros, or your factored form, sorry. Your zeros, well, we already know one of them is 1, another is -1, and another is -1, right? So we have x equals 1 and x equals -1. I need to set both of these equal to 0 and solve. We add 3, divide by 2. We subtract 3. So we get zeros of 3/2 and 3. So in all of these, the -1 came from here. So -1 has multiplicity 2. All the rest of them have multiplicity 1. That means whenever you write out your x-intercepts, we have 1, 0. I'm going to skip the -1. We have 3/2 0, and we have 3, 0, and all of these are cross points. Then we have -1, 0, which is a touch point. Okay, so if you're asked to do that, these are all your zeros, these are all your x-intercepts, this is multiplicity, these tell if they're a cross or touch points. Finally, we can find our y-intercept. Remember, that's where x is 0. So we just need to find out what y is. In the original function, if all these are zeros, then we just have a 9 left over. So that's our y-intercept. Now we have a whole page full of information here, but most of the stuff from our graph is going to come from these points and our end behavior. So let's do this. We have the point 0, 9, 1, 0, 3/2 is 1.5, so that's really close, 1.5, 3, 0, none of those are negative, right? Oop, it is a -3. That's a -3 right there. Hope you watched this till the end. That's a -3, which means we don't have this point. We have this point right here. Sorry about that. So this is -3, and we also have -1. We also know that our end behavior does something like this. Down on the left, up on the right. So we know it's going off this direction, and we know it's going up this direction. Have to make sure I use the right point there. So at 1, 1.5, and at -3, it's going across. But at -1, it's going to touch. So this one is going up somewhere, coming back down. It's touching, going back up, going through the y-intercept, going back down and across, and then coming back up across. So that is a crazy looking polynomial, but that is a general idea of what it looks like.